Today we will study session 9.2, Geometric Series. We first introduce the definition. A geometric series is a series. It's finite series or infinite series, where the ratio between successive terms is fixed. For example, sigma 3 to 2 power n, and from 0 to 5. So this sum, if we expand when n is 0, it's 3, then plus n is 1, it's 6, then plus 12, plus 24, plus 48, plus 96. So this is a geometric series. The ratio between successive terms is 2. In general, a finite geometric series has the form sigma I from 0 to n plus 1 axi. So this is a plus ax plus ax squared plus ax to n minus 1. This is a finite geometric series. While an infinite series has the form sigma n from 0 to infinity ax to n. This is a plus ax plus ax squared plus ax n minus 1 plus ax n. This is an infinite geometric series. The sum of a finite geometric series is given by the sum of a finite geometric series is given by Sn is the sum of the first n terms. So it's a plus ax plus ax squared, and the nth term is ax to n minus 1. So its sum is a times 1 minus x to n divided by 1 minus x, provided that x is not 1. So this is the sum of a finite geometric series, the sum of the first n terms. So next we'll look at the infinite geometric series. So recall that the sequence s to power n goes to 0 if x less than 1, as n goes to infinity. So if the absolute value x less than 1, then the sum of a finite geometric series is equal to this one. So this will goes to a over 1 minus x, because this one goes to 0. So as n goes to infinity. So in this case, we see that the infinite geometric series converges and has the sum a over 1 minus x. So we can write the infinite geometric series. Its sum is a over 1 minus x. if x, the absolute value x less than 1. If the absolute value x greater than 1 and a is not 0, so have ax to n will goes to infinity as n goes to infinity. So as n cannot converge. If x is 1, a is not 0, so as n is a plus a plus a is equal to na. So it does not converge. Finally, we look at the case if x is negative 1, a is not 0, so Sn is a minus a and plus a minus a, and next one is negative 1 and minus 1a. So if n is odd, then we have this sum is a. If n is even, then this sum is 0. So also does not converge. So if the absolute value of x greater than or equal to 1 is not 0, then the infinite geometric series diverges. So now we make the following conclusion. So the infinite geometric series converges if the absolute value x less than 1, strictly less than, and its sum is a over 1 minus x. If the absolute value x greater than or equal to 1, then the infinite geometric series diverges. Now we look at an example. Determine whether the following series converges or not. So the first one is 1 plus 1 half plus 1 fourth plus 1 eighth. This series. So this series, using sigma notation, this is sigma n from 0 to infinity 1 over 2 nth power. So for this case, we have a is 1, then x is 1 half. The 1 half absolute value less than 1. So by this conclusion, have the series is convergent with sum. The sum is a over 1 minus x. So 1 over 1 minus 1 half. So this is 2. Next one is this series. 1 minus 7 plus 49 minus 343 plus. So if we write it using the sigma notation, so this is negative 7 to the power n, and from 0 to infinity. So for this case, our n, a is 1, x is negative 7, and the absolute value negative 7 greater than or equal to 1. So by the conclusion we made here, the absolute value greater than or equal to 1, the infinite geometric series diverges. So the series is divergent. So the infinite geometric series converges when the absolute value x less than 1 and its sum is a over 1 minus x. If the absolute value x greater than or equal to 1, then the infinite geometric series diverges.